Hey guys, and welcome back to another video on the channel. In today's video, we're going to be looking at this physics projectile problem, okay? So a catapult is 1.5 times 10 to the 2 meters away from a 20 meter high castle on the top of a 31 meter hill. This catapult launches a metal ball at 50 degrees to the horizontal, and it's 3.5 meters off the ground, and the velocity of this thing is 45.8 meters per second, okay? Calculate how far above the castle wall it passes H. So pretty much here, it's getting shot, it's going to go overhead, and we got to work out this physical distance it misses, okay? Now, with this question here, we don't need to work out the time it takes to go up. So let's say the time it takes to go up there, and then the time it takes to go across, okay? Because we've been given this horizontal distance here. Now, the one thing that horizontal and vertical motion have in common is the time of flight, even though they're both independent things, okay? So here, we can use this number here, and we can also use the horizontal velocity we can work out from this vector component here. So this would be u of x. So this would be 45.8 cos of 50 degrees, okay? So here we also know what our s of x is, okay? So because there's no acceleration in the horizontal direction, we can work at the time of flight using this equation here. So the horizontal distance is equal to the horizontal velocity of the object times by the time of flight, okay? So here, we can just chuck that number into the calculator, so 45.8 cos of 50, and that's going to give us about approximately 29.43, okay? Or let's just go 4, because the next digit was 9. So here we can just substitute this information in. So we have 1.5 times 10 to the 2 equals 29.44 times by t. Now to get the time of flight, divide both sides by 29.44. So time of flight will be 1.5 times 10 to the power 2 over 29.44. Okay, then we just chuck that into the calculator as well. Unless you can do that in your head, but I can't do that in my head, unfortunately. Divide by that. So here your time of flight is approximately 5.1 seconds, okay? Now, thinking about this realistically, well, the thing is about this, no object really goes that fast, but we're thinking about like a catapult or like a medieval thing. So the time of flight being 5 seconds, given that distance, but also given that speed, that actually seems realistic, okay? Or you'd hope so, anyway. So now we've got the time of flight. We've got to think of the vertical motion, okay? Because notice here, this is going to be vertical distance here. Now, what I didn't notice about the first time I tried this question is here, this cuts through here as well. So if we're talking about the vertical, so this is your SY. So your SY is here. This, if we're trying to calculate that physical distance at the time of flight, we need to pretty much, add that 3.5 meters, okay? Because notice here, we're just assuming from here onwards, if we want that actual physical distance there, we have to add the 3.5 meters, okay? So here we've got the time of flight. We've also got the initial vertical velocity, okay? So we also have u of y, which would be 45.8 sine of 50 degrees. Chuck that into your calculator. So 45.8 sine of 50. That should give you about 35.08 meters per second, okay? So here we know u of y, your initial velocity, so 35.08 meters per second. We're trying to find this sy, so sy is your unknown at the moment, okay? We also know acceleration due to gravity, which is negative 9.8 meters per second squared. And we also know the time of flight, which is about 5.1 seconds, okay? So we can use this formula here to work out that vertical displacement. But of course, with this guy here, if we actually want the actual sy, we need to add that 3.5 onto the end. Because notice here, if we were just to calculate that, it would only give us this green distance here. You would calculate that. If you want the actual blue distance here, you need to add that 3.5 because remember it's pretty much above the ground, okay? So here what we do now is we just substitute, alright, that number goes into there. This number goes into there and there. And then this number, let's use this guy, pink, that would go into there, okay? So your SY, that blue physical displacement, would be 35.08 times by 5.1 plus a half times negative 9.8 times by, what's it called, 5.1 all squared plus 3.5, okay? Now, once you do that, you're hopefully going to get a number about, what did I work out before? 55.107 meters, okay? So that is that physical distance there. This is 55.107 meters, that blue distance there, okay? Now, we can also represent that distance using this sum here as well. So notice this distance is also this number plus this number plus this. So all of a sudden we get pretty much this nice looking equation. We have s of y, so we have s of y equals this, but we also have s of y is equal to 31 plus 20 plus h, okay? So 31 plus 20 plus h. So we can make them equal to one another, okay? So you get 55.107 equals 31 plus 20 plus h, okay? You can move these numbers across, so you get 55.07 minus 31 minus 20 equals h. Just chuck that into your calculator now. So 55.017 minus 31 minus 20. So you get h is approximately 4.017 meters, okay? So that is that little distance there, okay? And that's how you do this question. When I first did it, I did the time up and time down. I went a very long route, but this way is actually a lot better, okay? Because we had that distance there. Without that distance, it would have been a lot harder, okay? But overall, not too bad of a question. I can see why it's maybe 6 marks, because you would probably go this way, but looking at the working here, definitely worth 6, not worth any more or any less, okay? If you have any questions about this question here, leave something in the comments and I'll try my best to answer it, but I'll see you in the next video.